So problem number 4 says, what percent of the normal curve is not between negative 0.8 and 0.8? Okay, so I'm going to still do it the same way. All right. Hey, buddy. I'm glad you made it. Okay, so question number 4. So that 0.576 is what the area is. So what I would want to do is I would want on the next line down just do simple arithmetic, go 1 minus 0.576. So 42.4 or 0.424 is the area that's in either the two tails. Does that make sense?
One more time. I'm sorry.
Okay, so do you remember a term that was saying find? So this is the area that's in between. The entire area is 1 or 100%. Okay, so if you go 1 minus 0.576, that's going to give the area here and here, which is 0.424. What else did you see that I can help you with? 5? You got it. All right, a college professor, this is number 5, or number 5. A college professor decides to grade using z-score for every test. His grade curve is shown below. Z above 2.0 is an A z-score that's between -5 and up to 2 is a B. Z-score of -1.5 to -0.5 is a C. A D is -2.5 to 1.5. And F would be less than 2.5. Okay, what percent of his grades will be in each category? Okay, so we can still use our normal distribution. Okay, it doesn't really matter what the scores are. So I'm going to do, I want values greater than 2. So 2 to infinity. So from 2 to infinity, you're talking about 0.022, 0.023. So you're talking about 2.3% of this class would earn an A. Does that make sense? Okay. And then the amount of people that earn a B would be negative 0.5. Negative 0.5 to 2. So 66.9% would earn a B according to his rubric. And then if I went from negative 1.5 all the way up to negative 0.5. Oops. So that means that 24.2% would earn a C. And then, hey there. 2.5 to negative 1.5. So that means that 6% would earn a D. And then negative 2.5. In infinity. So that means that 0.6% would earn an F. Two places to the right. Yeah. What I basically do, I mean, you got what, 12 digits up there in a decimal. So I kind of look at the first three, and then you saw 0.006 is the next number big enough to make it 0.06, 0.07. Now it's not 5 or greater. So then if I move the decimal two places to the right, then it's 6%. 0.6%, excuse me. So obviously in that case, so it says for number 6, explain the consequence of using a normal CDF to calculate the percent of each letter grade. In fact, if his grades are not normally distributed, may be skewed left. So that is the problem. We don't know if his actual grades themselves are a normal distribution. The hard thing is when you collect data, as far as a class goes, the class is not a normal distribution. It's not a random sample. Like, let me ask you all this, and you're not going to upset me if you don't raise your hand. How many of you took this class because I was the teacher? 1, 2, 3, 4. 4 of you? Okay, and the rest were randomly put in here.
I took it.
First period. First period, who's the stirrup character? That's okay.
You know, if I was always talking trash on that sprout, I hope he's failing.
Were they saying bad things about you guys?
They were saying bad things about stats. He was like, oh, if you take stats, you're taking the easy way out. You're only taking it because you're stupid. Like, bro, no one wants to try hard for this here.
Well, I don't think this class is completely taken away from anyone's intelligence. I think there's an awful lot this class offers. Honestly, I prefer to teach this class than AP Stats because I'm not bound by, yeah, I don't have a test that I need to be teaching you to the test to do. I get to kind of broaden your horizons. Plus, we get to use Desmos, and I think, how cool is Desmos? I think it's a heck of a lot better than busting out where you have, you have 3 kids with one type of calculator, 7 with another type. A bunch of them might all be TI, but some of the operating systems on some of the TIs don't work the same. And then you got the Casio kid that walks in. And then you have the kid that walks in with the Hewlett-Packard reverse polar notation calculator. I don't even know how to turn those on. I mean, it's a whole thought process that this dude has never gotten. So. Well, yeah. Yeah, I mean, I don't feel like we're having to search for a lot of stuff on Desmos, which I think is a positive thing. Like if we do this on the calculator, we have to go stat, edit, enter your data, list 1, list 2. There's always going to be one kid who will delete the very top L1 because they don't hit clear, they hit delete. And then it's gone. And then we have to go through the whole notion of getting the L1 put back in. I used TI for many years, and I thought it was great. And then Desmos came along, and I'm like, dude. And then y'all went and bought expensive phones, and I'm like, dude, we can put this on their phones because they all have it.
Oh, STDEVS, standard deviation.
What other questions do you have on page 182?
Number 8.
Z-scores theoretically have no upper or lower bound. Okay. Therefore, observations that are off the bell curve are unlikely but not impossible. 8 standard deviations above the mean would be very rare. What percent of normal curve is greater than a z-score of positive 8? Okay. So what I'm going to do here is I'm going to pull it in 8. The reason I can do 8 on this is because I have my mean being 0. I have my standard deviation being 1. So we don't have to count out things. And then infinity. So that is a let me explain what this number means. This number is a decimal. That's in scientific notation because decimals obviously can't carry out decimals that far. So the answer to this, if you were that one kid in CP Algebra 1, is like, dude, I can count. And you're like, okay. So the real answer to this is 0.000000000000006.
So how many zeros is that?
15 zeros. Yeah. So something that's 8 standard deviations. So I don't even know if we could make this show up on here. Let's see, 8 standard deviations below the mean. So I have to do like this. I don't even know if I can zoom in enough to. Desmos is going to tell me to stop zooming in a bit. Yeah, it's as far as it goes to the -9 power. So, yeesh. So it'd be really hard to see, but you're talking about the most ungodly small. If you wanted to figure out what the percent of that is, it's 6.22 times 10 to the -14%. Okay. Well, it's to the -16, so if you make it a percent, you multiply by 100, which means multiply that by 100, so it goes from -16 to -14. So it's still, this is what this is. What is it? It's what? 6.22. 6.22 times 10 to the -16, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, if I remove this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep, that's right. So if I wanted to make, so that's the area under the curve. Make a percent. You'd multiply it by 100, and so you'd get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 2 less zeros when you multiply by 100.
Okay.
I mean, that, like, this is, like, if someone says, hey, something's going to happen 8 standard deviations out, put some money on it.
Okay.
I mean, the chances of you, something happening 8 standard deviations out, like, you just think about the height. Well, do me a favor, will you Google, wait, I know this, but 69 inches is the average male height. Can somebody look in the U.S.? In the U.S. Yeah, 5'9". Someone find me the standard deviation. Someone look up the standard deviation of the average male height in the United States. Somebody Google me the average standard deviation of the average male height. 3 inches? Wow. Okay. All right. So. Oh my gosh. All right. So 69 inches is the average male height. Standard deviation is 3. Okay. Now we want to get to 8 standard deviations. You agree? We saw that was a pretty small number. All right. So So if you think about this, 69 is the average. One standard deviation is 72, 75, 78, 81, 84, 87. So that's 1, 2, 3, 4, 5, 6, 90, and then 93. Okay, how tall is 93 inches in feet? How many times is 12 going to 93?
7'9"
7'9". All right, now, I think the tallest man in the world that ever lived, look that up. I think it's over 8 feet. 8'11". Oh my gosh. Okay, so there was a person who was 8'11" tall. Okay, so think about how many standard deviations beyond that would be. So help me out. What is 8'11" as in just as true inches?
272 cm.
I don't want centimeters.
What do you want?
8'11" just as inches.
Who's going to do that?
Just do 8 times 12 for me. What's 8 times 12? 96. 96 plus 11. So this is 107 inches tall. All right, so let's go. Keep going. So 96 is 9. 99 is 10. 102 is 11. 105 is 12. And 108 is 13. So this person is between 12 and 13 standard deviations above the average height. So if we thought 8 standard deviations was a really small percent, 13 standard deviations is ridiculous. It's like it should not have happened, but it did. But so supposedly, my great-great-great-great-grandfather on my grandmother's side at the time was the largest or the tallest man alive. So we're talking about it was like in the 1700s. And I kid you not, there was like some documentation that my grandma had, and I'm like, this is before computers. This is before.
Sounds like the tallest person in this house.
Yeah, like he wasn't 8'11", but he was at the time the tallest. I don't even know if his last name was Curran, because I don't know where the exact lineage. It came from my grandma's side, but you have mom and dad,
Get married and the like.
Yeah, I'm not quite sure what the name was, but there was this random fact. I mean, we're talking before cable TV, before Netflix, before the internet, before computers were in homes, before you had a calculator that was any bigger than a 4-function calculator, and add, subtract, multiply, and divide. This is when this information was told to me, and I just remember we were wowed by it. We couldn't disprove it. It was just verbally told. So, yeah. I don't know. So there are extremely very unlikely events taking place. I mean, this guy who was 8'11", 13 standard deviations above the average height. I don't even know. Okay, so let's do this. 13 standard deviations. Actually, do me a favor. I want to find this actual z-score. So I'm going to go 107 minus 69 over 3. What is 107 minus 69 divided by 3? It's going to be 12 point something, I believe. Minus 69. And then whatever that answer is, divide by 3. One decimal. 12.7. So the z-score is 12.7. So if we were to go and do this back on Desmos, so we can go 12.7 standard deviations. So how likely could someone be taller than this? Okay, that being 12.7 standard deviations is z-score. 2.95 times 10 to the negative 37th power. So you're talking 0.35029. Like, dude, it's not going to happen. But clearly it did, because there are photographs of the world's tallest guy. And if you've ever been to the Guinness Book museums, they have statues of how tall this guy is. I actually heard, if you Google the statue of the world's tallest man and Shaquille O'Neal, look at the photograph. Like, Shaquille, y'all know, is going to be a big man. But I know there's a photograph of the world's tallest man statue and Shaquille O'Neal still standing next to it, and he looks like a child. Here, I'll pull it up for you. Let's see. Images. So we all know how big Shaquille is. Look how much bigger this guy is. Imagine him being your star forward on your basketball team. Okay, all you need to do is just throw the ball to whoever that guy is. And you just hold the ball like this, no one can get to it, and you're like, bloop. Crazy stuff. All right.